Pythagorean theorem and distance formula. So today we are specifically going to be talking about right triangles and how the Pythagorean theorem relates to them. So talk to me about legs of a triangle. When might you see legs of a triangle? What kind of triangles were we dealing with when we labeled legs and a base?
Isosceles.
Isosceles. Okay. And what was true about the legs? The legs. What was true about the legs? The legs were congruent in an isosceles and the base was not. Okay? So if we have a right triangle, the leg and the leg, the two legs, are going to form that right angle. Now sometimes they will be congruent and sometimes they will not be congruent. So sometimes it will be isosceles and sometimes it won't. But the key here is that this is the hypotenuse. Across from the right angle is always going to be the hypotenuse. Okay, so for instance, if we wanted to have a right triangle where the legs were congruent, what else would we know about that triangle? It is a right triangle and it is isosceles. What could you label in that triangle? You could tell that where the hypotenuse is, yes. What about some angle measures? What would those other two angle measures have to be? They are congruent, so what is their degree? 45. Okay? Because if there's 180 degrees in a triangle and there's that 90-degree right angle, there's only 90 degrees left. So if you split that exactly in half, you'd have 45 and 45. Okay? So you could label this 45, 45, because this is not only right, but it's isosceles. Now, they don't always have to be 45, 45, 90s. You could have something like this, where you have 15 and 75. And if all of the angles are different, all of the sides are different as well. So again, you can have a right triangle where the legs are equal, or you can have a right triangle where the legs are not equal. But one thing that we do know about the legs is that they are the sides of the triangle that form or create or make the right angle. They can be congruent, but don't have to be. And the hypotenuse, we just talked about the fact that it is always across from the right angle. And what's one word that we have used in the past that means across from? No? That means next to. Starts with an O. Opposite. So always across from or opposite the right angle. What else do we know about the hypotenuse in a right triangle? Talk to me about its length. Talk to me about the hypotenuse in a right triangle. What do we know about its length? It's longer than the other ones, right? Okay, so it's also always the longest side. Questions so far? Okay, I am going to skip the distance formula for just right now, and I will come back to the distance formula when we need it, okay? But for now, I'm going to go ahead and move down to the Pythagorean theorem. The Pythagorean theorem is only for right triangles. Nothing else. And in words it says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now that's a lot of words. But if we break it down, all it means is that c squared is equal to a squared plus b squared. This, my friends, is the Pythagorean theorem. Now the key here is that you have to put c in the right place. C has to be the hypotenuse. That is not an option. Oop, that's not what I wanted. My mistake. Okay, so like I was saying, C has to be the hypotenuse. That is not an option. Now as far as A and B, those can be interchanged, okay? Which leg you say is A and which leg you say is B really does not matter, because in the end you end up adding them. And if you had two numbers, say 4 and 5, if you said 4 plus 5, you get 9. But if you said 5 plus 4, you also get 9. So it does not matter the order of the legs. C does matter. That has to be the hypotenuse. It has to be across from the right angle. Okay. So looking at example 1, the first thing that we want to do is we want to label C. Which one should be labeled C? X, because it is across from the right angle or opposite the right angle. So this one is C. And then after that, it does not matter which one you pick as A and which one you pick as B. So I'm just going to say this is A and this is B. It's a right triangle, so we know we can use the Pythagorean theorem, which is C squared equals A squared plus B squared. Please write your formula and then plug in what you know. Well, what is A? Or I'm sorry, let's start with C. What is C? X. What is A? And what is B? With me? So if we simplify this down, we've got x squared equals, what is 5 squared? And what is 12 squared? If we add those together, we get x squared is 169. But that's x squared, and they told us to solve for x, or find the length of the hypotenuse. So what undoes, what is the opposite of squaring something? Square rooting, that's right. So if we square root both sides, yeah, you might remember this. If you square root both sides, the square and the square root undo each other. They're inverses of each other, and you just have x equals. And then does anybody remember the square root of 169? 13. Now, here's the key. You want to check to make sure that your answer makes sense for the problem. What did we say has to be true about the hypotenuse?
Longest.
Has to be the longest. Is it the longest? Yes. So we know that our answer makes sense. Example number 2. How is it different from example number 1? We know the hypotenuse, right? So we're finding a leg this time. So it's going to look slightly different. The process, however, is the same. So let's label C first. C is always across from the right angle. After that, A and B do not matter. Formula, C squared equals A squared plus B squared. And at the end of these notes, where should you be putting that formula? In your blue book. And what should you be putting along with the formula? A diagram, and all that stuff should go in your blue book when you're finished with these notes. Okay? If on a test or quiz you do not write the formula down correctly, so then your problem is wrong, no points. No partial credit, because you have that blue book to use. Okay? So let's plug in what we know. We know that C is 14, so we have 14 squared equals 7 squared because A is 7 plus x squared because B is x. So x is in a different place, but we can still figure out what these squares are. 14 squared is 196. 7 squared is 49 plus x squared. Now, how do we get x squared by itself? Because this time it's not already done for us. That's right, we're going to subtract 49 from both sides. And we get x squared equals what? 147. Because C is always across from the right angle, and we know that that's 14. Does that make sense? Okay, so to get rid of that square, we are going to square root both sides. And if you take the square root of 14, what do you get? We know that the square root of 144 is 12. Square root of 169 is 13. So is this going to be exact? No, it's going to be between 12 and 13, right? So if you put this into your calculator, the square root of 147, and round to the nearest tenth, that means to the nearest one decimal place, what do you get? 12.1 what? 2. So we'll round that to 12.2. Questions on that? 12.2, just to one decimal place. Okay, we're going to skip that checkpoint for now, and we're going to move on to the distance formula. So let's go back up to your box of vocabulary, and let's go ahead and put in the distance formula.